Alright guys, so I'm gonna do a little bit of a conic review with you, and I'm just gonna add these in to the correct pages like as we go. So I'm just gonna give you like random picture, equation, or information card, and then kind of go over what one it represents. So let's start with this one. This is an equation, and I mean, if you want to make a guess right now as to what it is, that's a good little test for you. But I can tell that this is a hyperbola because both x and y are squared. They're being subtracted with different denominators, and it's equal to 1. So if I go to my hyperbola page in here, which is 111, 112 in my notebook, because, well, you know what, I am going to turn to a graph on here. So in my little practice book right here, I have some space to do a graph. So using this equation, we got y squared over 9 minus x squared over 25 equals 1. And so for a hyperbola, we want to find our center. We're going to just do the easy ones. There's nothing up there being added or subtracted with x or y, so your center's going to be a 0, 0. I like to find my vertices next, and with a hyperbola, the most important part of the equation is whatever comes first. So since y is first, my vertices are going to be on the y-axis. So your x's will still be 0, but you're going to move up or down by however much is underneath it, except you always have to square root it. So kind of in the back of my mind, I'm always thinking not of just 9 and 25, but really 3 and 5. So because the y is first, we're going to have a vertex at 3 and another vertex at -3. Okay, so to help me graph my hyperbolas so that they look good, we also want to think about our asymptotes. And our asymptotes are always at a y equals mx equation. So really it's just a line with slope. A y-intercept is 0 since our center is at 0. And so to find that slope, it's always going to be the positive and negative values that I have up here, and we always want to do y over x because slope is rise over run. So 3 over 5. And then just for funsies, the foci or foci can be found. They're going to be on the y-axis along with your vertices because y was first. So it's going to be at 0, comma, plus or minus. And to find that focal length, we had to do the c squared equals a squared plus b squared. And these are already your a's and b's, so I do 9 plus 25, which is 34, and square root it, so plus or minus 34, which is almost 6, but not quite. Alrighty, so to graph, we're going to plot 0, comma 3, 0, -3, center at 0, 0, and from there I can do my asymptote, which is going to go up 3, right 5, and kind of get this. And then I can also go down 3, right 5. Now the focus is nice, like that focal length, because the further away your focus is from your vertex, the wider your hyperbola or parabola will be. So because this is at 3 and your focus is almost up at 6, 4, 5, 6 here, that tells me this is going to be a really wide hyperbola. And you can also kind of see that with the asymptotes because the x is so wide in this area. Okay, so there you go. One done. This one just fell into my hand, so we'll do this one next. So this card right here, I can tell what this one is going to be because I noticed that both the variables are squared. It's being added, so it's not a hyperbola. So it's either an ellipse or a circle, and ellipses will have denominators that are different, and a circle will not, so this is a circle. So if I go to my circle page, we can graph that boy because I've got a little bit more room to graph. So with the circle, there's really just two things we're looking for, and that is the center, which are the numbers inside, just opposite. So the number with x is 4, The number with y is going to be -1, so that's your center. Then we want the radius, which is just always the square root of this here, so forth. Okay, so I'm going to plot 4, -1, and then I'm going to go out in every direction that's easy, so like up, down, left, and right, 4 units, so 1, 2, 3, 4, 1, 2, 3, 4, and I'm not going to be able to fit this one very well. It's definitely going to look like a potato. I'm so sorry. I didn't really think these through too well. I just grabbed them. Ah! Oh my god. Oh well. Circles are easy. Okay, this one's also falling off the page. So if I take a look at this one right here, I can tell pretty easily and quickly that this is a parabola because only one variable is squared. And unlike all the others, the standard form of a parabola has one variable on one side, one variable on the other. In all the others, the variables are together on one side and there's a number by itself on the other. So if I go to my parabola page, I can add this equation. And when we're doing a parabola, we want to find a couple of things. We want to find our vertex for sure. Now, because this is an x-equal equation, an x-equal equation is always going to point left or right. Because it's positive, it's going to go right. So I kind of like to have that that picked out of my brain first and like on the page so that I can see it, because then I have to remember like the vertex kind of goes in a different order. Like the number inside here with y is the y value, so it's not the number I want to write down first. Actually, -2, 1 is my vertex. Then we maybe want to find that focus and directrix. So to find the focal length for a parabola, that was that 1/4 times a, and a here is 2, so 1/8 is how far the focus will be from the vertex. And because my vertex is here, the focus is going to move in to the parabola there, so it's going to move to the right 1/8. So while the vertex was at -2, the focus is going to move in 1/8 from that, so it's going to be at -1 7/8, but it's still going to be at the same height. And then your directrix is going to go straight up and down, which is an x-equal equation, like x equal x equal. Similarly with a y equals, it's a y equals, so that's a nice little trick. And it still moves 1/8, but in the opposite direction, so it's going back from -2, so -2 1/8. Just because the other information with the parabola is kind of important. Oh, those two, and then it opens right. Oh, so we got it all. Never mind. So now if I just go graph this boy, we got -2, 1. Your focus is real close because 1/8 is a baby distance away, which means this is going to be a skinnier parabola. Because if your focus is close, then you're skinnier. And if your focus is far away, you're fatter. Parabola. pH fat. Okay. Next, if I have this one, we can probably guess because it's the last one we haven't done yet, but I noticed that both variables are on the same side, they're both being squared, they are being added, and they have different denominators, so I am an ellipse. So, if we go to our ellipse page, I think I got some room where we can graph here. So, in the numerator, I can tell where the center of my ellipse is going to be. It's whatever is in parentheses but opposite. So we're going to be at 3, -1. And then with an ellipse, now on your quiz it's going to ask you about which axis you're parallel to. And with an ellipse, the most important thing is whichever number is larger. So since 25 is larger and it's under x, you're going to be parallel to x, like the x-axis. So this is going to be a long, stretchy ellipse, kind of like this one, because x was large here, versus this one that's like parallel to y, because it's larger along y. Which, since you're parallel to x, your vertices are going to be at the same height, but they're going to be further away from your x center. by 5. So like with the hyperbolas, I'm really in my head thinking about this 25 is 5 and 4 is 2 because it's just the square roots of those. And so it's going to move 5 in that direction, so 8 comma negative 1. This is so not going to fit on my graph. And then 5 in the other direction, so negative 2 comma negative 1. Now that's like the long part of your ellipse. The short part are called co-vertices, and the x value of your center will stay the same, and now you're just changing the y height by a smaller amount, which is 2. So when I add 2, we're at 1, and when I subtract it, we're at negative 3. And then we can talk about the focus, although I don't think I put any focus stuff on your quiz. But like if I'm graphing this, we got 3 comma negative 1, and we're going to go 5 in the x direction, 1, 2, 3, 4, 5. So I'm at that negative 2, negative 1. Also 5 in the other direction, which kind of goes off my graph. Oopsies. And then I go 2 in the y direction, up and down to get those co-vertices. You can also see what that major axis length is. So I traveled 5 away in both directions, which means that its length was 10. And then I traveled 2 away in both directions, so that length is 4. Now you can kind of just count it, but it's also when you take the square root and double it, because like the square root is how far I'm going to travel in each direction, so that's twice, so that's why we double it. Now the focus we find by doing our focal formula, which is c squared equals a squared minus b squared, and we always want to subtract so that we're positive, so 25 minus 4 is 21 in square rooter, which is like less than 5 but more than 4, and we're going to add and subtract that to the x value because the x value is larger of the center, so 3 plus or minus the square root of 21 comma negative 1, and I mean like it's close because it's going to go 1, 2, 3, 4 and some away, so it's going to be close to those vertices but not quite there. Okay, so some other ones to try really quickly are maybe the reverse of those, because I put those on there as well. So like on your assessment, you're going to have some equations and you're going to have to tell what those are, but then you're also going to have some graphs and you're going to have to tell me about the equation. So I think looking at the graph and knowing what it is probably easy because duh, hopefully it's a parabola. But you're also going to want to be able to write the equation. And so on Desmos, you can click on the graph to be able to see better, but like I can write the equation of this graph. I know it's going to be a y equals graph because it's pointing down. The big thing I have to figure out is the a value. I can also tell that it's going to be like x squared, and I can find the vertex, and those are the points that go inside the parentheses and then at the end being added or subtracted, and we are right 1 up 1, so minus 1 but then plus 1 because anything in parentheses is opposite. Now on the Desmos quiz I plotted the focus point and the directrix so that you can find this better, but like the focal length I find by doing that 1/4 a, and so if I know because you were told that the focus is at 1,7/8, like I can tell that this compared to the vertex, which is at 1,1, is 1/8 away. So that's equal to 1/8. So I just have to figure out what a is there, which I can kind of tell that it's 2, but also like you can cross multiply if you're feeling a little bit scared about it being in the denominator. So 4a equals 8, and so a is 2. And so that tells me my a value was 2. So hopefully that's not so bad. Okay, if I have a different graph, something like this, hopefully that's kind of easy. That would be a circle. And so I know that a circle equation is always like parentheses squared plus parentheses squared equals the radius squared. And so I just got to find that center, which again, like on Desmos, you can click on the graph and get closer and count better because this is kind of tricky. 1, 2, 5. Seems to be over 5 up 1 would be the center. So right 5, up 1, because we're going to do opposite. And then I have to count the radius. So from that center, we want to count how much out, and it seems to be 1, 2, 3. And I'm not going to put 3, I'm going to put 9, because you got to square it. Okay? Or you might have a graph that looks like that little cutie. That's an ellipse. And with an ellipse, it doesn't really matter the order that you put this in. So usually I just go with, you know, x first, and then it's always a plus, and then y squared over something, and it's always, always, always equal to 1. So on top, I just got to find that center, and it seems to be to the right 1, so minus 1. And then down 1, 2, so plus 2, because we want to do opposite. And then underneath x, I just have to find the distance that I travel in the x direction to the end. So like here's the center, and if I go over 1, 2, 3, I get to the end, but not 3, 9, because you always square it. And then I have to count the y direction as well, and so it's up 1, 2, but not 2, 4, because I want to square it. So we can hopefully go backwards as well. And then, last but not least, we could do hyperbola. So, with the hyperbola, the order does matter. Now, I know it's like a fraction minus a fraction equals 1, but it matters what I put first, x or y, because that's the important thing about a hyperbola, whatever's first. And so, since my hyperbola branches are crossing the y-axis, y has to go first. And then x would go next. And so normally up here we would put our center, but our center is always 0, so really I didn't need those parentheses and that big long spaces, and now it just looks awkward, so I'm going to redo it. So y squared over something minus x squared over something equals 1. Now to find these, it's important to count the slopes of your asymptotes, although I guess I can find the first one because the vertices are how far you are away from the center. So since you're 2 away, you would take 2 and square it, so 4. But then you kind of do want to find the slope so that you can find the x value, because really that's the only way you can find what's under x. So like I had to go up 2 and then over 1, 2, 3. Maybe it's not on here. Maybe it's 5. But you'll be able to see it. So let's say that it was 5, underneath you would put 25. Like you'll be able to see the next nice point that it gets to, so that you can count that rise, run, slope, and then you just want to square those numbers and put them over there. So yeah, hopefully that helps, and I gave you guys a little practice worksheet, because it's mostly just graphing or identifying things from the graph or writing the equation backwards like this. So good luck, and we'll talk more tomorrow at our Google Meet.